We're now going to do an exercise to discover the important relationship between exponential and logarithmic functions. First, we want to find the inverse of f of x equals a to the x. So remember, to find the equation of an inverse function, we first rewrite the equation in y equals form. So we'll write this as y equals a to the x. And remember, we want to switch the x and y values. So that's another way of swapping domain and range, which we know are swapped on functions and their inverses. So we can rewrite this as x equals a to the y power. So right here, this is a form of the equation of the inverse, but we want to get this y by itself. So if we want to write this with the y isolated, we're going to have to get the y out of the exponent. So let's use logarithms to rewrite this exponential equation. So we can rewrite this as log base a of x equals y. So now we've got the y isolated, and finally we just want to write it with our inverse function notation. So we have log base a of x equals f inverse of x, or I'll turn it around, f inverse of x equals log base a of x. So you can see that the inverse of this parent exponential function is a logarithmic function. Okay, let's go the other way. Let's find the inverse of log base a of x. So I'll first write in y equals form, y equals log base a of x. So I want to switch my x and y's to find my inverse. So I'll rewrite this as x equals log base a of y. So again, here, now I want to isolate the y, write it in y equals form. So I'm going to have to write this in the equivalent exponential form to get this y out of the argument. So I can rewrite this as a to the x power equals y. So there's your y isolated. And then we just rewrite that with our f of x notation, or f inverse of x notation. So we have a to the x equals f inverse of x. And I'll just turn it around. F inverse of x equals a to the x. So we've just discovered that f inverse, the inverse of a to the x, is log base a of x. And the inverse of log base a of x is a to the x. We just discovered that both ways. So it's an important relationship. So y equals a to the x and y equals log base a of x are inverse functions. Very important property, important relationship. So we can just switch the x and y values of the ordered pairs on an exponential function to get the corresponding ordered pairs on the logarithmic function. And this is a very useful way to graph these. It helps you guys when you graph these. So since log and exponential functions are inverses, we know that the domain of log base a of x will be equal to the range of a to the x. And then the domain of a to the x is going to equal the range of log base a of x. And if you just want to put a little line here, those kind of ran together. So domain of one is equal to the range of the other, just like any two inverse functions.